Okay, here are example problems for motion in 2D. Number 1, a stone is thrown horizontally at 15 meters per second from a cliff 44 meters high. How long does it take the stone to reach the ground? Okay, so here's a diagram, cliff 44 meters high, and the horizontal velocity is 15 meters per second. Okay, the stone will take a parabolic trajectory to the ground. Okay, now the reason it takes parabolic trajectory is that gravity acts in the vertical direction, whereas the horizontal velocity has no effect on gravity. Okay, the horizontal velocity is separate from the vertical. All right, so what that means is the gravity acts equally on an object projected horizontally, which will land here, as an object that is simply dropped, which lands here. Gravity acts equally on both. Okay, so instead, to find the time of flight to here, which is hard, we can do it easier instead by just simply finding the time it takes to drop the same vertical distance. And that's the method that we are going to do. Okay? So, if we want to find the time, and we're going to find this time now, the time it takes to drop, here's my data. It's going to displace itself negative 44 meters. It's going to be accelerated by gravity. And we're going to consider that the initial vertical velocity, the initial velocity being dropped, is 0. Okay? These quantities will lead us to this equation, which we are ultimately going to solve for t. So let's do that. Now let's plug in 0 for the initial velocity. That takes that term away, makes that a little bit easier. Then we're going to multiply by 2. Okay. Now, remember we want t, so we're going to divide out the g to get t squared is equal to 2d over g. All right, and then we're going to take the square root. All right. Okay, now let's plug our values in. The displacement, negative 44 meters, g is negative 9.8. Negative signs cancel themselves out. The meters also cancel themselves out. And if you operate your calculator, you should come up with a time of 3.0 seconds. So it takes 3.0 seconds to travel this path, and it also takes 3.0 seconds to travel to A. Gravity acts equally on both. Okay, part B. How far from the base of the cliff does the object land? So now we're talking about the horizontal displacement. Now remember, gravity acts only vertically. The horizontal motion is completely unaffected. Okay, so what that means is the motion in the horizontal is at constant velocity. It's not accelerated. Okay, again, we are neglecting air resistance and all that. But then the motion in the horizontal is at constant velocity, so now we can use d is equal to v times t, where t was the 3 seconds of flight time, and v was the horizontal projected velocity of 15 meters per second, which leads us to an answer of 45 meters. All right. Okay, that's example number 1. Let's check out example number 2. A stone is thrown horizontally at 10 meters per second from a cliff 78.4 meters high. How long does it take the stone to reach the ground? Once again, here's my diagram. Once again, the path, the time of flight for each of these paths will be the same. So it's easier to find the time to drop 78.4 meters. So let's do that instead. Okay, here's my data. Once again, the displacement being negative 78.4 meters. We're going to consider that vertically it drops from rest. Okay, and then that leads us to this equation again. Let's run through the algebra again to solve this for t. First of all, I'm going to put the 0 in. Then I'm going to multiply both sides by 2 to eliminate the 1/2. Now divide out the g. And finally, take the square root. And this is what we get. Inserting my values, okay, the negative signs will once again cancel themselves out. The meters will once again cancel themselves out. And the seconds will come back on top. And the time in this case is 4 seconds. All right. Part B. How far from the base of the cliff does it land? Once again, we know that gravity acts vertically, okay, only. The horizontal motion is completely unaffected by gravity and therefore is at constant velocity. The only thing that gave the object its horizontal velocity was the launcher, be it a cannon or a person or whatever. Gravity acts only vertically. Okay? And neglecting air resistance, the velocity in the horizontal will not change once it is launched. That means that we can use this equation. D is equal to V times T. Inserting my values leads me to this answer right here, 40 meters. Okay? Okay. Example number 3. Here we have a steel ball with a constant velocity of 0.8 meters per second, and it rolls off the edge of a table. The table is 0.95 meters high. How far from the edge of the table does the ball land? Okay, same thing. We are given the horizontal velocity and the height. We can find the vertical or the time of flight by, once again, using this expression. We're going to consider that, and again, the initial velocity was 0. We plugged that in. We ended up solving for t. Okay. Now, rather than do this over and over and over again, we're going to take a little shortcut. And you should put this equation right here into your equation bank. Okay. This is the time of flight for an object dropped from height h, dropped from rest, or from height h. Okay. And rather than go through that algebra over and over again, let's just have this special case equation in our equation bank. Label it with this text, time of flight for object dropped from height h. Okay? It'll make our computations a little bit shorter, because we're just going to do that derivation over and over again otherwise. So, let's use this. T is equal to 2h over g, where the height is now 0.95, and I dropped the negative sign from the g. Because we know that the displacement is negative and g is negative. They'll cancel each other out. We know that. So we'll just ignore that. And then when you plug this data in, okay, your calculator will say 0.44 seconds. That's the time of flight. And then to get the horizontal displacement, okay, v sub x is 0.8. So we can use our horizontal motion at constant velocity equation, plugging in our numbers, and the answer turns out to be 0.352 meters. Okay, so use the height and this sort of shortcut equation, t is equal to root 2h over g. That will give us the flight time, whether it's dropped from rest or projected horizontally. And then use that in the horizontal d is equal to v times t expression. Okay. Equation number 4. We have a ball thrown horizontally from a 122 meter high cliff, and it lands at 52 meters away. Okay. First of all, how long was the ball in the air, the time of flight? Remember, that depends only really on the height. Okay. Now, but we can also determine that from, once again, t is equal to root 2h over g, where h is now 122 meters. So, plug that data in, operate your calculator, and you should get a result of 5.0 seconds. Alright? Okay, part B. Now I want to calculate the horizontal velocity. Well, before I was given the horizontal velocity and I wanted the horizontal distance. This time I'm given the horizontal distance and I want the velocity. We still can do that using d is equal to v times t. Let's solve this for v by dividing out the t. And now let's plug in our numbers. 122 meters, 5 seconds of flight time. That yields an answer of 24 meters per second for a horizontal velocity. Okay? All right, let's do example number 5. Now we have a stone thrown horizontally from a cliff and lands 4.5 seconds later out here, 36 meters away from the cliff. Okay. Now, this time we want to find the horizontal velocity. Notice that you are given the horizontal distance and you're given the time. All right, so now we can use d is equal to v times t once again. And solving for the velocity, inserting our numbers, we get an answer of 8 meters per second. Okay. Second thing to find out, how high was the cliff? We'll consider that it takes the stone 4.5 seconds to get on its parabolic trajectory. That would be the same as it were simply dropped. So once again, let's just consider it dropped from rest, and it takes 4.5 seconds to reach the ground. Okay? V sub I, t, remember we have g, and we want d. That leads us to this equation. Okay? Vertically, it's the vertical initial velocity is 0. Okay? And now we can simply plug in our data. All right? 1/2 times negative 9.8 times 4.5 seconds. Don't forget to square it. And if you operate your calculator, you will get an answer of negative 99 meters, which leads us to the conclusion that the cliff is 99 meters high. Okay? So just given different information, we can find different things. But remember that the time of flight for an object projected horizontally and an object dropped from rest, those times are equal. Okay? And one other thing to remember is the motion in the horizontal is at constant velocity. Those two important concepts will help us with these problems. Okay. Now let's make it a little more interesting. Now let's fire a projectile at an angle. All right? So we have it 196 meters per second velocity out of the gun at an angle of 60 degrees. First of all, let's find the vertical and horizontal velocities. So we're going to draw components. V sub x being the horizontal component, V sub y being the vertical component. All right? And then we're going to use SOHCAHTOA. Okay? Now, for the V sub x, it is the adjacent side. Adjacent and hypotenuse are related by the cosine. Cosine is equal to adjacent over hypotenuse. So 0.5 is equal to V sub x over 196. Multiplying each side by 196, and we get an answer of 98 meters per second. Now let's calculate V sub y. V sub y is the opposite side. Opposite and hypotenuse are related by the sine function. So the sine of 60 is equal to the opposite over the hypotenuse. Sine of 60 is 0.866. V sub y over 196. Multiply by 196. And it yields an answer of 170 meters per second. So those are our two components. Okay? All right. Part B. Find the time the projectile is in the air. Okay? Now, the projectile is going to take this parabolic trajectory to the ground. Okay? All right? And as in earlier cases, the gravity is unaffected by any horizontal motion it has. So really, the time of flight only depends on how fast it is going up. How fast it's going horizontally plays no role, because gravity acts only vertically. Okay? So really, the time of flight depends only on its initial vertical velocity. So it is as if we shot an object straight up with a velocity of 170 meters per second. Okay? If the times of flight for an object that travels this path and for an object that travels straight up with the same initial vertical velocity, those two times will be equal. We're going to take advantage of that fact. Instead of calculating this time of flight, which would be hard, let's calculate the time to go straight up and come back down. We've done that before. Okay, this goes back to our motion problems. So the initial vertical velocity is 170 meters per second. It's acted on by gravity. We want the time of flight. Okay. Oh man, we need that one more known. Well, if you remember, we did this little trick where we considered only the first half of the flight, because that allowed us to say that the final velocity of the first half is 0, and that gave us that third known that we needed. Then, using these quantities, we can use v sub f is equal to v sub I plus gt. And we have to solve this for t. Okay? I'm going to put the 0 in. And now I want to isolate the t. I have to get rid of the v sub I. So I'm going to subtract it. Then divide out the g. Let me get this. All right? So the time is equal to negative v sub I over g. Okay, let's plug our numbers in. Okay, negative 170 meters per second over negative 9.8 meters per second squared. All right, negative signs cancel themselves out. So do the meters, and so do 1 of the seconds. And if the second is in the denominator of the denominator, it comes back on top. And then my calculator said 17.3 seconds. This is not the total time, however. That was just the time to the top. To get the total time, we have to multiply by 2. Up and down. So I multiply that by 2, and it's 34.6 seconds for the total time of flight. Okay? So, instead of finding the time of the parabolic path, find it straight up and down with the same initial vertical velocity as the vertical component of the velocity. That's the time of flight, 34.6 seconds. Okay. Next, we want the range, how far it goes horizontally. Okay. Well, remember that the motion in the horizontal is affected only by the launched velocity in the horizontal. Gravity does not affect that at all. So once again, motion in the horizontal is at constant velocity. And we can use this expression, d is equal to v times t. V sub x now is the horizontal component of the original velocity, 98, and the time of flight was 34.6 seconds, which gives me an answer of 3,390 meters. Okay? Once again, the motion in the vertical is affected by gravity. Motion in the horizontal is not. Okay, now let's find the maximum height that the projectile reaches. We're looking for the vertical displacement. Okay, now the height reached depends only on 2 things: how fast it was going up and the time it took to get there. Okay, which are related actually. So here's my data table: v sub I, g, considering only the first half, 17.3 seconds of flight time to get there. All right, and I want to use, and I can use this expression. Incidentally, you could have also used v sub f is equal to 0 in a different motion equation. I just chose to use this one. Okay. All right, let's plug in our numbers. 170, 17.3 to get to the top, 1/2 negative 9.8, and then 17.3. Don't forget to square it. Got to be careful with your calculator on this one. Okay. I did these separately. The first term was 2,940. Don't forget the negative sign here. That does matter. First one turns out to be negative, or the second term is negative 1,470. So then my answer ends up being 1,470 meters. That's how high the projectile goes. Okay. All right. Let's move on to example number 7. A projectile is fired at a 53-degree angle with a velocity of 200 meters per second. Letter A. Find the time the projectile is in the air. Okay, in order to do that, we are going to need to find the components. The x component, and particularly the y component. All right. Usually, you need both components in the problem. So I'm just going to go ahead and solve for v sub x anyway. Okay, cosine is adjacent over hypotenuse. Okay, that's what my calculator gave me for the cosine of 53 is equal to v sub x over 200 multiplied by 200, and the v sub x equals 120 meters per second. To find v sub y, we're going to use the sine function, opposite over hypotenuse. Sine of 53 equals v sub y over 200 multiplied by 200, and my calculator said 160 meters per second. Okay, so here are my two components. Now, to find the time of flight, as in example number 6, we are going to consider an object projected straight up with an initial vertical velocity of 160 meters per second. We're going to consider the final velocity being 0 at the top, and then we're going to find the time for the first half. Okay. Once again, these quantities are related by v sub f is equal to v sub I plus gt. Plug in my 0. We want to solve this for t. Plug in my 0. Then we have to eliminate this term, which we can do by subtraction. Okay, and then we're going to divide out the g. Negative v sub I over g is our result. Now, let's plug in our numbers. Negative comes from the algebra, 160 meters per second divided by negative 9.8 meters per second squared. All that cancellation can occur. The negative signs cancel, the meters cancel, one of the seconds cancel. And your calculator should yield an answer of 16.3 seconds. Now remember, we want the time of flight, the time that it takes up and down, so we need to double this 16.3 seconds to get the total flight time. And when I do that, I get 32.6 seconds. So that's how long it was in the air. Okay? Part B. Find the horizontal distance the projectile travels. This is called the range. So to find the range, once again, remember, the motion in the horizontal is at constant velocity. So I can use this expression, d is equal to v times t. V sub x, the speed in the horizontal, is 120 meters per second. And the time is 32.6. So I'm going to plug that in. 120 meters per second times our 32.6 second flight time. And my answer is 1,960 meters. Okay? Okay, one more example to do. Example number 8. A golf ball is hit at an angle of 45 degrees with the horizontal at a velocity of 52 meters per second. Find the range. Okay? All right. It turns out we have a number of things to do in this problem. Okay? I'm going to end up using d is equal to v times t to find my horizontal range. All right? But I know neither v sub x or the time of flight. So I need to determine each of these. Now the first step is to break up this 52 meters per second into components using SOHCAHTOA. That's our first step. Okay? All right, so let's do that. We know that the horizontal component is the adjacent side, and the adjacent side and hypotenuse are related by the cosine. So the cosine of 45 is adjacent over hypotenuse. Cosine of 45, 0.707, equals v sub x over 52. 36.8 meters per second is my result. Okay. For v sub y, the sine of 45 is opposite over hypotenuse. Turns out the sine of 45 is the same as the cosine of 45, 0.707. After multiplying by 52, we get the very same 36.8 meters per second for the velocity. Okay, so here are my components. Okay, now I want to find the flight time. That depends only on the vertical velocity. Okay, 36.8 meters per second initially. Final velocity of 0 on the top for the first half of the flight. Okay, I'm going to use v sub f is equal to v sub I plus gt. Plugging in my 0. Remember, I want to solve this for t. Okay, got to find the time that it's in the air. So 0, plugging in for final velocity, subtracting out the v sub I, dividing out the g, gets me to this expression. I'm now going to plug in my numbers. Negative from the algebra, 36.8 meters per second over negative 9.8 meters per second squared. Lots of cancellation occurs. Negative signs, meters, 1 of the seconds. And the time ends up being 3.75 seconds. That's the time to get to the top. The total flight time can be found by multiplying by 2. And so the total flight time is 7.50 seconds. Okay, now we know v sub x, and we know time. So let's insert these into the problem, and our final answer is 276 meters for the range. Fairly well hit golf ball.